In this video, we are going to go over how to do each of the problems for quiz number 1, version 1. You're going to want to have your formula sheet handy. We're going to be mainly dealing with the Pythagorean identities, the reciprocal identities, and the quotient identities. So for the first question, we have cosine x times cosecant x. Remember that you're trying to change everything to be in terms of sines and cosines. So I'm going to leave the cosine alone, just bring that down. That doesn't need to change. And for cosecant, well, cosecant changes to be 1 over sine of x. Now nothing crosses out because there's nothing that's the same at the top and the bottom. So we're just going to multiply. When you multiply fractions, you just multiply straight across. So cosine x times 1 gives me cosine x. And then there's only a sine x in the denominator, so that just stays. Now cosine over sine is a quotient identity. Cosine over sine is equal to cotangent x. Now for problem number 2, we are also going to put it in terms of sines and cosines. So cotangent x becomes cosine x over sine x. Now that is being divided by cosecant x. Cosecant x is 1 over sine of x. Now remember, whatever you have in the denominator, you're going to flip it and multiply. We're going to multiply by the reciprocal. That's what it's officially called. So after you move it up to the top and you flip it, that one goes away. So now I have a sine at the top and a sine at the bottom, so those cancel. And I have cosine x at the top over 1 at the bottom. And cosine x over 1 simplifies to be just cosine x. For number 3, we're also going to put them in terms of sines and cosines. So for cotangent, you don't want to change it to 1 over tangent because that doesn't have sines and cosines in it. You want to change cotangent to be a quotient identity, which is cosine over sine. Now, secant x is a reciprocal identity. It changes to 1 over cosine x. And then sine does not need to change. You just need to bring that down because it's already a sine or a cosine. Now remember, if you have 1 at the top and 1 at the bottom, you can cancel them out. And I have a sine at the bottom and the top, so that all cancels. So since everything cancels, your answer is 1. Now for number 4, it's a little bit different than the other 3 we've done. Number 4 is going to use Pythagorean identities. So we are just going to look at cosecant minus cotangent. Sorry, cosecant squared minus cotangent squared. That's right here. That equals 1. So this whole section becomes 1. And then you're going to bring down the plus tangent squared x. Again, you can find that under the Pythagorean identities. 1 plus tangent squared x equals secant squared x. For number 5, we have a setup for a distributing problem. So I'm going to do 1 times 1, you get 1. 1 times negative sine x is negative sine x. Sine x times 1 is positive sine x. Sine x times negative sine x is negative sine squared x. Now negative sine x and a positive sine x, those can cross out because they make 0. So you're left over with 1 minus sine squared x. That is a Pythagorean identity. 1 minus sine squared x equals cosine squared x. Now for number 6, you can do it one of 2 ways. You can do it the GCF factoring way. And that's where you recognize that sine squared x is repeated. So you have 2 sections here. You have this section, and they both have a sine squared x, so that goes out in the front. Now after I get rid of the sine squared x, I have a cosecant squared x left over, minus, and everything in part 2 there canceled, so you write a 1. Cosecant squared x minus 1. Cosecant squared x minus 1 is an identity, a Pythagorean identity, and that equals cotangent squared x. And then you'll bring down your sine squared x. Put it in terms of sine and cosine, so cotangent squared. You would do a quotient identity. Cotangent is cosine over sine, so cotangent squared is cosine squared over sine squared. And then bring the sine squared down again. Now I have a sine squared at the top and the bottom, so those cancel. And I'm left with a cosine squared x. There is another way to do this problem. Let me show you that real quick. Do it on the whiteboard here. So number 6. We can put it in terms of sines and cosines. So this sine is okay still. This cosecant, we would need to change. So that sine squared x is okay. This cosecant squared x is going to change to 1 over sine squared x. And then you have a minus a sine squared x. Now we have a sine squared x at the top and the bottom, and you can cross those out because they're multiplying. So from this part, we have a 1 left over. Then you bring down your minus and your sine squared x. And that is a Pythagorean identity. 1 minus sine squared x is cosine squared x. So we get the same answer either way we do it. All right, on the back, we have a fraction problem here. Now we need to have the same denominator in order to combine these. So we have a denominator of cosine x, and this one needs a denominator of cosine x. So we're going to multiply cosine x at the top and the bottom. So now my shared denominator is cosine x. My numerator is sine squared x. Plus cosine times cosine gives me cosine squared x. sine squared x plus cosine squared x is a Pythagorean identity. It equals 1. And the denominator is cosine x. Now you don't want to leave your answer as a fraction, because 1 over cosine x can simplify. 1 over cosine x, it can simplify to secant x, right from right here. So my answer is secant x. Now for number 8, 1 plus tangent squared x is a Pythagorean identity. You would change the 1 plus tangent squared x to become secant squared x. And then the 1 plus cotangent squared x is cosecant squared x. After you do the Pythagorean identities, you want to use your reciprocal identities to change them in terms of sine and cosine. So secant x is 1 over cosine, so secant squared would be 1 over cosine squared. And cosecant is 1 over sine, so cosecant squared would be 1 over sine squared. Now remember, whatever's in the denominator, you're going to multiply by its reciprocal, so we're going to flip it. And after you flip it, you can get rid of it at the bottom. So I'm focusing on this multiplication problem right now. 1 times sine squared x gives me sine squared x. Cosine squared x times 1 gives me cosine squared x. I'm left with a fraction, but sine over cosine is tangent, so sine squared over cosine squared would be tangent squared. Now the following are verify problems. For verify, it's where we draw the little line coming down from the equal sign, and we try to get from one side to the other. You always want to start at the most complicated side. So I'm going to start on the left side here. I'm going to change everything to sines and cosines. So cosine can stay, but secant has to change to 1 over cosine. Cotangent, we don't want to use the reciprocal because that doesn't have sines and cosines in it. We want to use the quotient. So cotangent is going to become cosine over sine. So we're going to take our denominator and we're going to multiply by the reciprocal. We're going to get rid of what was in the denominator. So cross out what's the same, and I'm just going to rewrite it so everybody can see. One pair of the cosines crosses out, so we got one at the top and the bottom. And then nothing else crosses out, so we have 1 times sine, which is sine. And in the denominator, we have cosine. And sine over cosine is a quotient identity, which equals tangent. So we have gotten from the left side to the right side. And the last one, number 10, I'm going to also start on the left side. Tangent squared x plus 1 is secant squared x. That's a Pythagorean identity there. And then secant squared x minus 1 is tangent squared x. Also a Pythagorean identity. Change them into sines and cosines, so secant becomes 1 over cosine. So secant squared would be 1 over cosine squared. Tangent is sine over cosine, so tangent squared would be sine squared over cosine squared. You want to take your denominator and multiply by the reciprocal. I'm only crossing over the line here because I ran out of space. Get rid of it in the denominator. So I'm going to just rewrite the top, which we're focused on right now. 1 over cosine squared x times